everyone, I'm Nikki Nielsen and I'm a postdoc here at Swinburne in Melbourne, Australia. So today I wanted to present some new results looking at the CGM at cosmic noon with KCWI from our paper that we published back in December. So we presented the first results from this survey, which was outflows from a star-forming galaxy at redshift 2.07. So we've put together a sample of about 15 quasar fields with at least 2 magnesium-2 absorbers between redshifts of 1.9 and 2.6. And we've known that there are a lot of archival data for these fields. In particular, there's a lot of high-res or UVES quasar spectra with many known absorbers in these fields. And there's also quite a bit of HST imaging on these fields. Recently, we went back and obtained NERC2 data for a couple of the fields. But the thing that's been missing for redshift 2 CGM studies has been the galaxy identifications for the most part. Luckily, we now have KCWI, which we can use to look for Lyman-alpha emission at these redshifts. So thus far, we've put together a sample of 15 fields where we already have all of the quasar spectra, the imaging, and the KCWI data. And we know in these quasar fields, we have at least 30 magnesium-2 absorbers, about 80 carbon-4 absorbers, and this consists of almost 100 unique absorbers. So from these data, we hope to build a sample of about 30 to 50 absorber galaxy pairs in order to do some detailed redshift 2 studies that we can compare to lower redshift. But today, I'm presenting the results from the first field that we looked at, which is J1430. So here on the left is an HST image with the quasar centered in the field of view. And then on the right is a KCWI white light image that consists of about 1.4 hours total exposure. So we know that there's a magnesium-2 absorber in this field at redshift 2.07. And we did find Lyman-alpha emission from a galaxy about 66 kiloparsecs at this redshift. We also see this galaxy in the HST image. So if I zoom in on that galaxy, you can see it here on the right. So it looks to be this clumpy edge-on disk with its minor axis pointed towards the quasar. It's possible that this is also a major merging system, although we rule that out in the paper. So please have a look at the paper for that discussion. We know that this galaxy is star forming. It has a star formation rate of about 40 solar masses per year. And its redshift is offset by only about 30 kilometers per second from the CGM absorption. We also have a UVES spectrum for this system. So we have coverage of Lyman-alpha, as well as magnesium-2, which was a requirement for this survey. We also have several silicon lines, carbon-4, and nitrogen-5. So with these data, we're able to look at the magnesium-2 kinematics, as well as the total metallicity for the system. So here is a plot showing the total metallicity as a function of azimuthal angle. And we aim to populate this plot with redshift 2 systems with this survey. But in the meantime, I've plotted our J1430 system with lower redshifts points from Poynton et al. 2019, and Lyman limit systems and DLAs at redshift 2. So we found that this galaxy that we've observed has a CGM metallicity that's relatively metal enriched compared to typical Lyman limit systems at this redshift. So given all the galaxy properties and the absorption properties, we concluded that this is most likely to be outflowing gas from the galaxy. We also explored some other scenarios in the paper, so please have a look there for discussion of that. But given that we assume that this is outflowing gas, here are all the values that we measured from the system. And then we also did a little bit of outflow modeling to get some typical outflow characteristics from the system. But I wanted to highlight that all of these properties that we've measured are the same amount of detail as we typically measure at lower redshift. So this is really interesting in that we're able to now do more of a consistent redshift evolution and do a nice comparison at all of the redshifts. But at the moment, I'm currently building the catalog and hope to get about a sample of 30 to 50 absorber galaxy pairs. So stay tuned for the catalog, as well as for more interesting science results to come out. Thanks.